Hello, good morning, students. Today we will talk how to solve the system of linear equations in R. In our theory class, we have taught several methods to solve system of linear equation, including matrix method, Gauss elimination method, Gauss-Jordan method, and some of the iterative methods. So for this particular tutorial, I am going to copy and paste a simple example in which we have to find x1 and x2 and solve this particular system of linear equation. All right. So let's start. But before we start, it is always a good practice that you clean your console, your environment in this part, and your plot. So to clean your environment, just click this button, click yes, and then you can clean. Similarly, in here, you can clean. And finally, in the console, just press Ctrl L, and you will see the console is clean as well. For this particular tutorial, I am using MATLAB package in R, and in our class, we have discussed in detail how to install. Let's just activate this MATLAB library and run it. Now the MATLAB library is activated. If you want to see, just go to the packages and you will see that the MATLAB library is checked. So the first thing is that for the system of linear equation, we need to create a matrix. Let's create a matrix A. So I know everyone already know how to create a matrix in R. So I will use the command matrix. My data will be equals to -9, comma, -3, comma, 5, comma, and -2. Number of rows is equals to 2, and number of columns is equals to 2, and by rows equals to 2 as well. So students, if you just put number of rows equals to 2, so R by default consider it number of columns equals to 2 as well. But for the practice, I want that you guys still use these arguments. We have created a matrix A and run it. So on the right side, you can see the matrix A is appeared. If you click on this matrix, you can see the matrix. If ever you want to print it, you can print it. If you want to print it in console, it will be over there. Moreover, you want to view in a new window, in a new tab, just write view A, and then you can see this matrix. For now, I will deactivate or comment this one by pressing Ctrl-Shift-C because I don't need it anymore. Next step is let's create a matrix B, the coefficient matrix 2 and 9 by same command. C is equals to 2, 9, and number of rows is equals to 2, number of column is equals to 2, by row is equals to true. And I created another matrix. So in here I did a mistake. The number of columns should be 1. So I will recreate it. B is equals to 2 and 9. Right? So in our class, we have talked about that we need the matrix A and the matrix B. So let's just solve it. So in R, you can use the command solve, and you will see that there are two solve. One is from MATLAB, one is the base. I prefer to use MATLAB package and solve it. And we have to put the matrix A, comma, B. And let's run it. My answer is 0.6969 and x2 is equal to -2.75. So they gave me two questions. One is A, is there a solution? The solution always exists if a matrix is non-singular. What does it mean? Non-singular mean the determinant of A should not be equals to 0. So let's check determinant of A. Again, I'm going to use the MATLAB package. You can use the other package as well, like the base one, but I'm going to use MATLAB package and put matrix A, and the methods should be cofactors. And I run it. So once I run it, I get 33. It means that the solution exists. So my answer for the part 1 will be solution exists since determinant of A is not equal to 0. In the next part, part B, they ask you if solution exists, check if it is a unique or infinitely many solutions. Sometimes it is possible that the system of linear equations have more than one solution. All right, so let's check. Part 1 is completed, that the solution exists because determinant of A is not equal to 0. In part B, we will solve A and B and check the answer. We solve it, we get x1 and x2. So it means there is a unique solution. Unique solution means these two lines, they will intersect only at one point. You can use solve in R base package, and then just write the same, and you will get the same answer. You will get the same answer in here. Now let quickly try to visualize our result by plotting these two lines. For this one, again, I am going to use Matplotlib package, and I will use plot equation function and write A, comma B, and it will plot on my right side in here. So these two equations, they intersect at a point in here, and this is called the solution of your system of linear equation. All right. Now, this example is solved. Let's try to solve another equation with 3 variables. I'm going to copy another example and paste it in here. Again, I'm going to comment it by pressing Ctrl, Shift, and C. Now, I am going to create the matrices A and B. Let's say matrix A is equals to matrix, my theta will be equals to -6, comma, -10, comma, -1, comma, -9, comma, +5, comma, 6, comma, -3, comma, -7, comma, and 1. And my number of rows are 3, number of columns are 3, and pi row is equals to 2. I run this matrix and I create it in here. In a similar way, I will create another matrix B, matrix C is equals to -1, comma, 0, comma, 2. Now number of rows is equals to 3. Number of column is equals to 1, and by row equals to 2. Sorry, it's capital T. I run it again and I get matrix. For the part 1, is there a solution? We will check very quickly the determinant of A by using cofactors method. Determinant of A is -270, so it means solution exists. I will write solution exists, right? In our next part, which is part B, if solution exists, then either it is unique or infinitely many solution. Let's just try to solve it by using the Matplotlib package in R, A, and B. So our answer is x1, x2, and x3. So you can see that there is a unique solution over here. All right. If ever we try to plot equation A and B, you will get an error. The error is because this particular plot equation function uses 2 variables, but in our case we have x, y, and z. All right, so we have to use plot 3D and then run it. So once you run it, you will see a new window will pop up in your computer. Let me just make it in here. And you will see this is the green line. It represent one equation, red line represent another equation, and blue line represent another equation. So three of these equations, how they intersect, you can rotate it by just clicking the mouse and rotating your mouse in here. So I'm going to close it. So this is your system of linear equation with three variables. Also, it is possible that we can use Gauss elimination method. For that, you can use Gauss elimination and try to run A, B. You will get your answer. So everyone know that in theory class, we talk about how to solve using Gauss elimination method. And we make an argumented method, argumented matrix, and this part is your solution. All right. Also, if you want to see that the row operations, you will just add the command verbose and put it true and run it. You will see that in your console, a step-by-step procedure, how they made the left-hand side equals to identity matrix and how they get the solution. All right, so you can use it. Also, you can use the other technique. For example, you can say that Gauss elimination method